Hello, everybody. Welcome to this platform. This is Sichamba Jacob right over here. And I'm pretty sure, as usual, you are doing pretty well. Look at this. We've got a question right over here. We need to find angle BAC, CBD, ACO. There are three angles that we're supposed to find right about now. It's very important that you understand the question when you've been given any question on Seco theorem. Should I say you understand the statement that you've been given? We've got this statement right here. They're saying center O. So meaning this is a center right over here. Don't mind where it is. Just know that it's a center O. BD is the diameter. And when we talk about a diameter, we're simply talking about the length or the distance passing through the center, touching both sides of the circle or the circumference. So the distance from here all the way to here, it's the diameter. And the reason why we're saying it's a diameter, it's passing through the center. This is the center O. Okay, so here the question continues, or the statement continues. AD is equal to AC. So where's AD? AD is equal to AC. So when you see something like that, what kind of triangle are we dealing with? You can see the signs right over here. It's showing us this is an isosceles triangle which we are dealing with. So now from here, there is another statement which says that and angle BDC is 22 degrees. So there's an angle here which is a 22. If you're able to see nicely, for question A, there is no need of calculating here. Just say the answer is a 22 degrees. I know some of you may be asking me that, how did I know that it's 22? There is a property which we use for us to find angles like on question A. Look at this. Can you see this chord right over here? This chord. There is a triangle which is coming from this same chord, touches the circumference, comes back. Again here from the same goes, touches the circumference, and then comes back. So this angle will be equal to this angle. Let me show you something. When you've got a circle like this, you've got a chord. There is this angle which is formed right here. Can you see this angle? If another angle is formed right over here, this angle will be equal to this. And this is what I'm using. They are all coming from the same segment, touching the circumference, and then goes like that, touch the circumference. So the angle here will be equal to the angle here, which is a 22 degrees, just like that. Let's check out question B and C, what we're supposed to do on question B. For question B, they're asking us to find angle CBD. Where is C? C is right here, and then B is here, D is here. Here, guys, you don't need to think very much. You don't need to think very much. There is a property which says that when you've got a triangle which is formed inside the circle and it's passing through the center, one angle there is 90 degrees. Look at this. When you've got this, the way it looks, and then this is your center, there's a line that passes through here. It forms an angle right here. So you can see there is a triangle inside the circle, and this triangle is passing through the center, meaning the angle here is 90 degrees. So you can see that this is like this. At C is 90 degrees. So we've got two angles, 90 and 22. Therefore, we can find the angle at B. So let me clean up here so that we do our calculations from here. We're going to say 90 degrees plus 22 degrees. This is giving us a 112 degrees. So the sum of this angle and this is 112 degrees, of which if I want to find the angle here, I'll just say 180 degrees minus 112 degrees. Property of a circle, this will give us 68 degrees, meaning the angle here is 68 degrees, which is our answer. For the last question right here, this one, let me do this. So for this one, they want us to find the angle ACO. So angle ACO. ACO CO. We are looking for this angle. So what are we going to do here? This is where we need to be very smart. Look at this. This is a center. So this is radius and this is radius. So these two are equal to each other. We can therefore say this is what? It's a 22 degrees, if this is 22 degrees. And then we find an angle here. So to find an angle here, we're going to say 22 degrees plus 22 degrees. This will give us a 44 degrees. So this plus this is 44. To find this angle, we're going to subtract from 180 degrees. And when we do so, the answer is coming out to be equal to 136 degrees. Okay, so this is 136 degrees. Now remember here, so what happens is, since we found this as 136 degrees, there is a property which says that an angle here is twice the angle at the circumference. So what I mean here is that when you've got a circle like this, and this is a center, okay, coming from this segment, another angle is formed. So the angle here is 2 times the angle here. And this is a property we are using. We've got this angle. So this angle is 2 times here. For us to find an angle which is here, we need to get 130. We divide it by 2. So when we divide by 2, there it will give us a 60 degrees. So we know that this is 60 degrees. Okay? So once we get this 68 degrees, we are now going to find the angle here. Look at this. Okay, so to find that angle, we're going to say 180 minus 68 degrees, which will give us 112. Okay, so when we get this 112 degrees, it's actually the sum of this angle plus this angle. Remember, we're dealing with an isosceles triangle. So we're going to divide by 2, and this will give us a 56 degrees. So the 56 is an angle here, and also here it's 56. Now to find this angle that we are looking for, we'll say 56 degrees minus 22, and it will give us a 34 degrees. So our answer for question C is 34 degrees. Thank you so much for watching. Hopefully you've learned 1 or 2 things out of this video. Please keep on watching. Leave the comment in the comment section, share, and also like. This has been Isichamba Jacob, and bye-bye.